All right, so the topic is secure deployment in customer environment, right? A boring topic. But before I go there, let me check if you guys are really awake. So who are these people? Okay, how many people know at least one of these? Okay, two. All right. By the end of this talk, you will know about all these three great people, who they are. In addition, you will know their contributions to this presentation, which is even more important. So let me get started. All right. Customer deployments. Who loves customers? Who like customer deployments and upgrades? Exactly. That's my sentiment. And that's why this talk is here. So, from my battle scars as an engineer and learning from other people around me, this has been the problem. When we think about product, we think about product from the product perspective. The important part is the product is incomplete without the customer. So what we did, as people who know me, I like to plan. And I think really, really hard. And as Vivek says, I listen. So that's what I did. And I didn't do it alone. The goal was to create the best deployment strategy. And we are thinking, like, first few months, just jamming around. Okay. So while we were jamming, the battle scars, you'd never forget them. And then you hear the stories from the other lieutenants and commanders who have been there. You know one thing, which is common, which is no battle plan ever survives contact with the enemy. But since we are friends, there are no enemies, I did a mental substitution. No deployment plans ever survive with the customer. And this was reaffirmed by one of my friends from Habu while we were coming back after the first day blast, customer deployments. That's all we talked about. So, like most people, like a good Indian boy, I found refuge in Ma. That's what I did. And most South Asians got it wrong. And most non-South Asians aced it, what it means. I coined a term, mindset aware. What happened? Mindset aware architecture. So after defining these terms, we have to think what exactly this means. So this means let's go into the mindset of a customer and see if there's an alignment with us. So if you think about the customer, there are four basic questions in mind. Does it solve my problem? Right? Is it easy to deploy? Can I trust this product? Will it be reliable? Will it be compliant? And would it optimize my cost to value ratio? Right? And if you think about as a startup, what we think about, is this product relevant for the market? Which is a product market fit? I want to grow fast with a minimal cost. Deployments, delay in deployments, getting to the AHA value, all these things matter. And every delay is costing us. Nobody wants to get up in the midnight to solve customer problems. And we had a session around that a couple of days ago. So the goal is to create a system which is reliable. And at the same time, we want to stay ahead with the competition. Nobody sits in the cocoon and says, okay, I'm going to spend a lot of money and sell it to customers because, they are just going to buy it. It doesn't happen. So I got the help from Mr. Eisenhower, who says, in preparing for the battle, I've always found that the plans are useful, are useless, but the planning is indispensable. And again, I did the mental substitution. In preparing for deployments, you know, planning may be useless, but plans may be useless, but the planning is indispensable. So that's what we did. So all these things that these insights that I talked about, they translate into like 5 basic engineering translations. So one, make the entire infrastructure deployable as a code. Use serverless as much as possible in the customer environment. Loose coupling between different components of the product, but think from the security first perspective. Make your product configurable and extensible, either by you or your customers. And set up alerting and monitoring as a first class citizens, because most of the times it's the last thing we do. So how does the software architecture look like? So I'm going to talk in terms of abstractions and then kind of relate it to Markov. If you think about the software, there are 3 fundamental blocks like of any customer deployment. There are clients. It can be a web client, it can be an SDK, it can be actually a CLI. There are some kind of data processors in the middle which process the input coming from the customer. They do some massaging. And ultimately, these data processes might send that data to a proprietary backend, which we sell to the customers. So that's the crux. Now, the next step is, how does it align with the Markov architecture? So these are the high-level abstractions at Markov. You have the SDK and the CLI. You have the web client. And you have these building blocks. So a data processors layer, we call it interceptors and analyzers. Oh, sorry. So this is how the flow looks like. I won't go over the slide, but at the high level, we have all these components talking to each other. All these components are sending their logs to a centralized logging system. And as I said, like security first, we are taking the inter-service communication, and so communications between client and servers. We are making sure that the calls are made by the authenticated and authorized users. And some buzzwords. Because of this, we have scoped abstractions of our microservices. That means each microservice is responsible for doing one thing and only one thing. And we follow the Liskov substitution principle, which means that every service and its components are replaceable by the derived components. And as you can see, since we are serverless in the interceptor and analyzers, this entire infrastructure is off by default in the customer environment. Yes, there is an API gateway that is up, but that's the only thing. Now, how it translates to Markov, you can see here, these are the components. But you can replace this Lambda with Azure Actions or GCP functions. It doesn't matter because we have created an abstraction over it. Our analyzers run on Fargate, but you can also use Azure ECS. And our backend, which is proprietary, still runs on the Kubernetes. We use Fast API. And our storage is spread across S3, MongoDB, and time series DB. And we use, right now, Auth0 for authentication, but you can see this can, again, be abstracted out with any other provider. So basically, when customer tells us, hey, asks us, can I actually run it on Azure? The answer is yes, because we have created these abstractions upfront and the separation of concerns upfront. So there are always flavors. The customer wants their dinner to be served in different platters and different flavors. So Markov comes in 2 flavors. One is the Markov Cloud, which is completely managed by us. And the only thing that we provide to our customers are SDK and the web client. And all the interceptor, analyzer logic, all the communication between the proprietary backend is managed by Markov. Now, in some cases, customers don't want us to access their data. They want their data to be processed in their own environment. So for those customers, we have Markov Hybrid. So our SDK again runs on the customer machine, and our customer cloud and the interceptor and analyzers are running in the customer cloud, and they are communicating with our backend using again authentication authorization. So we know like who is accessing data and from where. But then, if you think about closely about this architecture, you know, Mr. Sunzu helped us to make decision. Was a big kind of an influence on this kind of architecture. One of the things we do uniquely at Markov is what Mr. Vaidya says: to know your customer, you must become your customer. So, if you think about these designs, Markov is actually a customer of Markov. So our interceptors and analyzers during the deployment, we tested hundreds of times because we deploy Markov as a customer of Markov, and which helps us to make sure that we are reliable, we are compliant, and when we, there will be surprises, but we are reducing the probability of that happening. So deploying Markov. So, we strongly believe like seeing is believing. So let me walk you through how you can get started with Markov Cloud. You do pip install MarkovML, and you can just type Markov in it. Authenticate with Google, and you are done. You have access to Markov Cloud now. And to deploy in the customer environment, we just created this 25-second video. Again, seeing is believing. You run just a bunch of commands. And this entire step takes 10 minutes to deploy the entire architecture in the customer AWS. And that's it. And these are the steps that you have to take. You just, again, install Markov. The only additional step you have to do is actually Markov deploy. That's it. And obviously, you need to have permissions to deploy it on AWS. But other than that, you're all good to go. Now, the upgrade is as simple as calling Markov upgrade. You don't need to do it because we are in the backend taking care of a lot of deployment. But there are instances where you may be using an ECR which is cached. So to prevent that, it's better to actually go and click Markov upgrade to make sure everything is up to the status. So under the hood, this is the architecture, what it looks like. There are all the complex logic, all the scripts and interaction with the cloud are abstracted out in our Bash and Python scripts, which internally calls into like different AWS services and sets it up for you. So at this point of time, there are 3 camps of people in this room. So one camp, whatever. The second camp, meh. And the third camp, it's cool. So the first 2 camps, I am responsible, and you all are going to get 2 parties today instead of 1. It's on Superset, not on me. So enjoy those for your time. And for the last camp, who says it's cool, it's a team. Because as this relatively unknown person said, great things in business are never done by one person. They're done by a team of people. And I'm super proud of the team at Markov. We accomplished all these things within a span of months, not even years. So that's what we have achieved. And relatively known person who says people, product, and customers in that order. And we really mean, like innovation happens when people get autonomy and people get chance to create magic. And that's what has really happened at Markov. So thank you, team, for that. While Vivek just disappeared, because if you have questions, Vivek was sitting just there. So you can find him and ask questions. But I can try my best. So that's it. I won't take much of your time. Any questions? Yeah.
Yeah, so considering your deployment model, instead of directly exposing, Python dependencies and then getting dependent on the person's host OS, virtual environment, have you thought of abstracting this out into a Docker container where instead of doing page install, you just do a Docker container?
Yeah.
Can you repeat the question?
So if you see most of the machine
Can you repeat
learning,
the question?
huh?
Can you repeat the question?
Yeah. The question is like, can you abstract out all the dependencies that you have in a Docker component that a person can deploy? So these are like SDKs and libraries. Like if you think about the Python development model, like all these libraries and SDKs are exposed through pip. So we don't want to change. Like data scientists, who are the primary audience for it, they're much familiar with pip and conda. They go and say pip install, and it works. And a lot of the dependencies that we have within our Python environment are actually what data scientists normally use, except the deployment part. So it's one additional layer, which is, again, we use a lot of AWS CLI right now, which is managed. So we don't have to worry about the compatibilities. So as I said, we try, and internally when we are testing, we try to deploy on different versions of Python, and we have a list of supported versions of Python.
Isn't that a challenge for maintenance where if I have a machine and if I have, let's say, Python 3.9, and if you're telling me that your CLI will only run on 3.8, so why have to install Python 3.8 as well?
Yeah, so most of the machine learning libraries, so here we have to think about the customer, like what's the problem we are trying to solve. So most of the customers in the machine learning world, they use machine learning libraries. One of the common distributions is Anaconda, but they can use PyTorch. They can use like different versions. So we try to maintain compatibilities with those libraries. So if you have 3.8, we are compatible. If you have 3.9, we are compatible. If you go to an experimental version, then we may not be compatible. We work, but we can't guarantee we will work. And again, right now, other limitation is we are only focused on Linux, right? So if you go and try it on Windows, we can't support it. But again, most of the data scientists and these libraries are compatible on Linux. So that problem is solved. Cool. Any other question? Yes, Sujan.
Hello. You said that no plan survives first contact with the enemy. What kinds of things have you guys seen at Markov had to change assumptions that turned out to be wrong?
Yeah, the thing is that, that's what I said, we have planned a lot, and we have practiced a lot. We have done a lot of like battle practices, but we haven't deployed yet to a customer in the hybrid mode. We have some customers which are using in the managed cloud mode, and we have filled those gaps, but the hybrid mode is going to happen soon. So before boasting in glory and calling it a victory, I just remind myself of Himmelt, that no battle plan survives the contact with the enemy, and here the enemy, substitution with customer. Yes, Anil.
We have a Python installer that we give to our clients as well.
Mm-hmm.
And the questions he asked are the same things that come every day in and day out.
Yeah.
There are customers who will be on 3.6. There will be customers who are on Windows, Mac.
Yeah.
Some flavors of Linux which has
Yeah.
some compatibility issue.
Yeah.
It comes day in and day out.
Yeah.
I don't think Docker is an answer though, because like now you have to install Docker.
Yeah,
which
exactly.
may not be.
Exactly.
But this is a problem that definitely comes, and we are facing that. So.
Yeah. No, that is we have been there.
Yeah. The second part is how do you upgrade, right?
Yeah.
I get the part where the software, the backend software gets updated. That's fine. But how do you like ask the clients to upgrade to the newer version of the installer itself?
Yeah. So what happens is in our UI, whenever the interaction happens, we kind of send in which version the client is on. So if they are on which version of Markov they are on, and if you have released a new version, you see a beacon on the top that on your machine, on this machine, this command is being, where you open this browser, this is the current version, and hey, you are these many versions behind. Go and upgrade.
Yeah, that definitely helps. We haven't added it to the UI. We have it in the backend, but we don't show it on the UI. But I think that's a very good idea to do that.
Yeah.
So one more thing. This is regarding the cloud infrastructure that you're deploying. So in that you mentioned that it's all serverless, but then how would everything be serverless? Like
Yeah.
If they need to interact, they need to have some connection, right? Like,
Right. So when I say serverless, I loosely said they're serverless. There's an API gateway in front which remains on. That's how your CLI communicates with your lambdas.
got it. So
And what we do is, so one thing that has happened is the entire regions fail. At time, like we have dependencies on cloud. So what we do is our these infrastructures are deployed in different regions. So when you upgrade, you actually get a new URL of a specific region that you can talk to. So that way, if a region is down, your system is still up and running. So it's not hard coded.
all right. And does that impact the client's cost? Because API gateway deployed is money, right?
Right.
And they may not want to use it the whole time.
Right. So the cost we have computed for keeping the API gateway in this mode, because it's not being called, is minusculous. It's there. I'm not saying it's zero, but it's not high. So the cost, the point is, at the point, you have to figure out the balance between, reliability and, experimentation, right? And I bet you if I tell customers that, hey, you have to pay X, which is not exorbitant, but you'll be reliable, they're happy with that. So that's the mindset.
Yeah, this is very similar to the Databricks architecture, I guess. The whole installation of the AWS infrastructure. Do you use CloudFormation or something for that, or is it entirely from CLI?
I think we use internally the CloudFormation and Terraform to deploy, but the entire credit goes to the infra team. So what they have done, it's great. Like we are replicating like $60 billion companies, so we are on the right track.
Yeah, that's the same pattern they use. So they have this API gateway in between, a bunch of lambdas behind it. So I think it's the same one. Nice.
Cool. What else? All right then. So I think this is the shortest. Cool. All right. Thank you. You get your time back.